Perfect. Okay, without further ado, I'd like to hand over to our first speaker to share their presentation, Andre Lamar from Olympus in Quebec in Canada, and he's going to talk about the digital solutions. And perfect, Andre, over to you. I'll mute my microphone shortly and we can see your presentation on screen. Thank you very much.
Thank you, Martin. Thank you very much for the introduction. I'm very glad that the transition went well. I was a little stressed about that, so it's great. So good morning or good afternoon, everybody. Welcome to this presentation about Olympus NDT digital initiatives. The purpose of this presentation, in fact, was to share with you some project that Olympus has been working on over the last years, and also some project in development that will be presented for the first time publicly. So this will be the schedule of the presentation. Okay, so Olympus NDT, as you know, is always committed to develop new and innovative solutions for inspection, test, and measurement requirements around the world. Now, in these days, it's more critical than ever to leverage the latest technology to minimize downtime and increase efficiency. So to do so, we address three major components: the Olympus Scientific Cloud, the connected devices, and the digital added values application. And this is what we're going to review into this presentation. A brief overview of the Olympus Scientific Cloud. So this is a single source hub to enhance device connectivity that allows easy data management, device fleet management, enhance visibility, collaboration around the world, simplify software updates for optimum equipment performance, and secure data storage that can be accessed instantaneously. We use the Microsoft Azure platform to build that cloud, so that makes sure that all the data are secure, because Azure has a lot of experience into that, and also offer multiple services that makes the development much faster and easier. So the Olympus has been involved with cloud since 2015, where we issued the Olympus OSC 1.0, but this was used only internally. So it was used internally to define do some fabrication application. And also we use this occasion to build the infrastructure and learn about the Olympus cloud maintenance and fabrication. In 2017, we issued the OSC 2.0, which was the first customer-facing cloud, where we were able finally to connect devices, and it was mainly used for data repository. This year, we issued the OSC 3.0, which is a platform built for the future. It enables rapid application development and deployment, and it allows for third-party application development. And of course, around it, we have some Olympus connected device, okay, that are around the central hub, which is the OSC cloud. Let's see that in more details in a few slides. The Olympus Scientific Cloud platform. So this is a platform that is very easy to access. So it's fully integrated to the Olympus website for easy access and login. So you just have to go here. If you go on the Olympus website, you go through this, little man here. You see that menu here, where you can log in to the OSC or log into the OSC marketplace. So this is free access, and everyone that create an account has immediately 10 GB of free storage available. The login is done through Microsoft O365 or also through the individual OSC account. So this is very convenient and very easy to access. So I invite those that didn't have a visit to this cloud yet to please pay a visit to it. So this platform, the idea is to simplify the workflow. So first you have My Organization, where the tenant can invite users and manage their roles. You can also manage your application subscriptions and storage. There's the Marketplace, where you can browse for free and paid applications that add value to your industrial devices. And you can also manage your devices. Means by that you can register your device and access relevant documents. You can remotely update the device firmware also on your fleet of instruments. And finally, My Data, where you can upload and store your files, data files or other files, and organize and tailor the data management. Use as fleet management. So this is one central hub. So you can here, when you go into My Device on your account, you can register new devices here by using that button here. You see two examples of device already registered. So you can have the visibility of this device serial number. This one here is 38 link. This one is a Vanta. So those, you can then save some data into those from these devices. You can also save calibration document and things like that. Here you have an example that the device is pending registration. So the user here tried to register his device. A PIN number was provided to him that he has to enter to the equipment in order to make the synchronization between the equipment and the cloud. Also, you can go on the marketplace. So this is how it looks like. So you have, in that case here, different applications that you can see. So as you will see with time, there are going to be more and more of this application available, rather to buy or rather to use freely. The connected devices. We have few instruments that are connected. This one is the Vanta, which is our XRF analyzer. It's connected to the cloud using wireless LAN. You can then do live data visualization from anywhere in the world. You can also embed the GPS to pair it to the XRF result so that you can see the location in a map of the result. The Vanta Data Viewer, which is accessible on the cloud, allow you quick and easy sorting of collected data and streamline reporting. The Epic 6LT, which is our flood detector, is also connected to the cloud through a wireless LAN dongle. With this one, you can perform wireless firmware upgrade, and you can also save your calibration certificate. And it allows file backup and archiving. So you can see here on My Data, under that device data, you see here the Epic 6LT, you see the serial number, and you see files that were exchanged with this instrument. So you can have CSV file, PDF, and so on. So that could be files that were sent to the device or received from the device. The 38 plus and the 38 link. So this is our thickness gauge that is connected. So this one is connected to send and receive information through the Bluetooth. It can also be connected to the cloud through the wireless LAN. So with the application named the IPM, which is the Inspection Project Manager, you can do fast data transfer from the inspection site, you can do fast reporting and decision making, and perform remote management and monitoring of project, job, and task. So this is actually available on the Olympus Cloud. Now we are working on this project as we speak to connect what we call the legacy OmniScan, which are the OmniScan MX, the MX2, and the SX. So this one now are connected to the cloud with the use of a USB Wi-Fi mass storage key. And the idea here is to allow bidirectional data transfer. So first example is from the OmniScan to My Data. So you see here the operator, which is in the field doing an acquisition, will send the information live to a gateway to the cloud. And this one, the information will be recorded into My Data. And then the specialist can access to it to make a review. So this you can save, you can share data files, print screen, report, setup, etc. In the other direction, if you have the analyst, let's say, or the supervisor at the office or in the lab that wants to send a setup to the user in the field, well, just the same way, he connect to his cloud account, transfer the data, and this data will automatically be transferred to the OmniScan. So this is presently in evaluation phase by some customer, and this is not commercially available. But if any of you would like to make a test or have some discussion around it, please don't hesitate to get in touch with me. And now, of course, I can hear a question, what about the X3? Well, the X3 will be connected to the OSC cloud before the end of 2020. So it's in a few weeks from now with its optional USB Wi-Fi dongle. So enough of instruments. So I reviewed the instrument, the connected devices. I review a little also the cloud. And now we're going to go where we have more value to the devices. So I'm going to present our first solution that we are working on, which we named the Oil and Gas Connected Digital Solution version 1.0, which is a cloud-based and tablet solution. So the objective of that solution or that tool is to provide a seamless solution to the asset owners and the ISP, the inspection service provider, supporting UT thickness for CML, corrosion measurement location, or TML, thickness measurement location, as well as visual inspection. So the idea is to ease the communication and data exchange between the asset owner and the ISPs, to improve data integrity by removing the paper and pen, improve efficiency by reducing reporting time, and perform live monitoring of inspection project advancements. All this using, in that case, the connected 38DL Plus with its 38 link. So this, we can also see it as, let's say, a collaboration between the asset owner and the ISP. So in that case here, what we're going to see it a little later, the asset owner easily assign inspection work. The inspection requests include all the necessary inspection files coming from an IDMS, which is the database, and the data is transferred safely and securely to the ISP. Then the ISP can generate projects from the inspection requests, and these projects are auto-populated with all the relevant information files from each asset to be inspected. And you can then assign inspector and approver for all the tasks effortlessly or easy. So this support the UTT non-baseline at the moment, and as well as the API visual inspection. It supports field data collection and reporting with or without internet, because when you go into the plant, the refinery, the internet is not always available. So you can perform the inspection with this, and when you get the connection, then the data will be transferred automatically. We offer the digitized isometric drawing for free-form annotating and redlining. So this is really the key of this solution, is the digitized isometric drawing, or digitized ISO, you can say as well. So this includes a patent pending interactive isometric drawing for UT data collection. It provides custom also UT and API visual inspection templates. So now we're coming with a digitized report. And these reports are auto-populated with collected data and photos as the inspector is doing the work. And at the end, the inspector can sign off on report directly on the tablet. So just to make a note about this, so this is the usual isometric drawing that is extracted from the IDMS that are used for inspection, combined to the survey file where you see all the different indications. So you have the CML position here, and you see here the CML and the previous reading and the next reading to come. So this is pretty much the way that is used today in the industry, rather with paper or rather with some digital solution. But from these, we combine these tools to create the digitized interactive isometric. So if I take a look at it, you see here, this is on the tablet as an example. You see all the CML, okay, that are present here. Some are visual, some are UT. And when you click on it, then you can see on this position the previous reading and the current reading that was just done, as well as the comment that the operator could have done during the process. And then finally, also have access to digitized report when you see all the list of the readings done, so that the report is almost fully completed as the operator is doing the inspection. So, to make it clear to everybody, I include a video where we're going to see all the workflow of using these tools. I have to apologize, that video is not, let's say, marketing type. It's really a shooting of all the different operations. And what we'll see there, it includes two different entities. On one side, you have the asset owners. On the other side, you have the inspection service provider or the service company. And in this company, we're going to have two actors. We're going to have the supervisor as well as the inspector. And the inspector also will be one UT inspector and one VT inspector. So during, excuse me, during the video, I will comment what's going on. I have to tell that the video lasts 9 minutes, 30 seconds. So please, I apologize if it's too long, but it's the best way I have today to give you really a good feeling of the solution. So let's go. All right, now you have this asset owner, okay, that needs to want to send an inspection request to have his assets inspected. So he goes on the application, he creates a new inspection request. We'll give a name to this request and a date for completion. Then he's going to select which equipment or circuits he wants to be inspected. In that case, it will decide to inspect those 3 vessels and will import and create a new event. So it's going to upload the information on a zip file that includes the FTP file and the CSV file that are previously saved in the IDMS software, which include all the information about previous inspection and also the detail of the assets to be inspected. Then he will decide which company wants to send the information. So he send then the job to this company named Inspection Service. And then he can review, okay, that, okay, you see all the air dryers, that's the right equipment and so on, is ready, will be ready, VT and UT is ready to send it to the ISPs. Now we see ourselves in the role of the ISPs. So the ISP now connect to the application or to his account. It will start the inspection management application and realize that he received new application. So now he will address it to a project manager and define it as active. So from that moment, the inspection request is transferred into a project that includes 3 jobs, so 3 different vessels, and on each of them we can see different task quantity that needs to be performed. So the supervisor in that case now will assign the UT task to one of his inspectors. So you have the list of inspectors always available. So in that case, he will decide to assign it to Sean. Okay, then he will do the same for the visual inspection. He will select the 3 of them. We'll assign it to a VT inspector. And we'll also define an approver of this inspection. So now the work assignment was completed. And now you can review and see, okay, everything is fine. You make it all the assignment good, perfect. You can look to the personal, you see that Steve has 3 tasks, completed 0. Preston has 3 tasks, completed 0. So it's a dashboard, in fact, of the work that was performed. Now, this is the ISP's user, the inspector. So now he's working on the tablet. He's logging in. You see that he received now a different job to be performed. So he starts with the visual inspection in that case here. So on the isometric drawing, while he does his inspection, he defines a point where he wants to add a visual event. So in that case here, he realizes that there's an inadequate support, that is not acceptable. He makes a comment about it. It's repair, could be anything. And then take a picture. And then all the synchronization will be done automatically. So he save it. Also can do redlining, so realize that there was a mod done during the last month to the circuit, so you can make some notes on the drawing itself and also do some comments. And then it will review the digitized report. So we have now the digitized report that is already pre-populated with its observation. You see inadequate support. And we're going to have access now to the picture. Look at the picture, his comment, everything is fine. Okay. So now he's ready to complete it. So the inspection is completed. And now someone, could be the same or someone else, can approve the work that was done from this visual inspector. So he uploaded the digitized form, make a review of it, add his signature, save it, and it's done. Now the UT Technics task. Same thing, the operator received on his tablet the task to be performed. So we open the task, and now he's ready to go. You see the isometric, interactive isometric with all the CML position. Now it will synchronize to his device, which is now the 38 DL Plus. And you see the previous rating of all the different that was done before. So now we don't see the UT device here, unfortunately, but right now he's doing some inspection. So he makes some reading. And he can also comment when it's required. Save it. So you see it's in red here because we put an alarm. So there's an alarm where there's more than 10% of difference with the previous reading. There's an alarm that alerts the inspector, say, okay, maybe there's something wrong. Maybe you can redo your reading or make a comment because there's too big of a difference with the previous readings. You can also do some redlining. The UT inspector can do that as well. And he can add CML. So can decide here that he will add some CML at this position on that new, let's say, pipe that was observed. Then during all this work, the report was auto-populated. So now you can review it directly on the tablet. Make sure that everything is filled properly. And now the task was successfully completed. Again, someone will approve the report. So we'll have access to the report that was previously done and sent by the inspector. And also the supervisor can review here the status of the work. So now you see that Princeton sent a report about VT inspection. Excuse me, I'm at UT inspection. Then he review it, see the comment. And we'll finally sign it. So now we can see here that the reports were done in the field and they are ready to go. So there's no time waste to go back to the office and do the reporting. So then we're back to we're going to send the information back to the asset owner. So the ISP supervisor send the information back to the asset owner. Now we're back on the asset owner side. The asset owner go on his account. We'll have a notice that he received new information from the ISP about those two events, which is UT inspection in that case. And he can have a look at it. We'll look at the report. See all the different readings, the annotations. We'll do the same thing with the visual report. And then the information will be sent back to the IDMS for archiving. So you export the information back to the IDMS. So this is the end of the process. Now we complete the full loop. So from the inspection request at the beginning to the inspection itself, the reporting, back to the asset owner. All right. So this is the end of the video. Thank you very much to have listened to this. Okay, now I will continue. A summary of the value that we get from this oil and gas digital solution. So on the inspection project management side, we can see that we can organize an effortless project creation and execution. It improves visibility to the personal and project status, increase efficiency in reviewing and approving completed work. On the inspection data side, it improved data integrity to fully digital UT and VT data collection. So there's no pen, no paper use. To reduce costs related to rework, because you have immediate result that you can share with the asset owner. Visibility and transparency to collected data in real time. On the reporting side, we have a significant efficiency improvement through automation, and that drives. Then we also enable significant future value, so we can build on that new applications. And finally, for the device management, improve visibility to allocated resources, the device consistency, and maintain higher quality assurance. What is the solution of that status? Version 1.0 is nearly completed and is presently to the evaluation phase by some customers. This is not yet commercially available. As I said, I'll present new development. So the presentation, demonstration, discussion with customers is in progress. Today is the first time that we make that presentation publicly. Version 2.0 will be released in 2021 with added features. There's other exciting digital project in progress actually. So we would like to hear about your digital journey and requirements. So please, for more discussion, don't hesitate to get in touch with me. Thank you very much.
Thank you very much, Andre. We're now able to welcome some questions from people. You can either put your hand up or ask a question directly. Also, we're using the chat facility as well. So during the talks or at the end of the talk, you're welcome to add a question to the chat and we'll then ask the speaker. So I'll make a start. There's a question from Keith Fine from GAL. Is there any way of validating the inspector ID? Keith, are you there?
Yeah. What at the moment in the current status of the solution, it is not possible. But this is a, let's say, one of the comments that we have almost every time that we present that to a customer, is to think of a way to include that. So this is something that will come through the development in the future.
Okay, thank you.
Do we have some more questions from Andre? Sika, would you like to ask a question?
Yeah, thanks, Martin. Andre, thanks very much. Fantastic presentation. I think you show us a key point of the process, the working process, and for me, it opens questions. How do we interface it to our company's infrastructure? As you are well aware of, the wall thickness measurements at the corrosion measurement locations are highly integrated in the IDMS systems in our companies. So there is a strong component already in place, and the execution part up front of it, that is, I think, what you are addressing. Do you have ideas how that might have to grow to get these worlds seamlessly together?
Yes, absolutely. In fact, we realized quickly that for each different, let's say, maybe for each different asset owners, let's say like Shell as an example, there will be some level of customization to be done in order to connect the tools together. All right, but this is something that requires, let's say, collaboration from everybody. So Olympus, our solution, shell that opens the access to the their IDMS or their open structure, and also the software. Maybe they're probably working with an external company also, so that we can all work together to find the best way, the more effective way to connect everything together. But we know this is absolutely something that we are getting geared to realize.
Yeah. I would say this is crying for end-to-end analysis, as we call it.
Exactly.
The whole value chain brought together and detailing out what are the steps that we actually want to make, not now, but in the future.
Exactly.
Yeah, thanks very much, André.
You're welcome.
Yes, Andre, I would highlight what Siga was saying, because it's very impressive the way you're going all the way through from the project management stage, carrying out the inspections, all the approval process, and passing things through to the asset owners. So quite a lot of the steps that Siga highlighted earlier are shown there. We've got time for some more questions.
And maybe I can make a note here that this was developed with the collaboration of asset owners. So we didn't define all this in our corner, right? Thinking of the best solution. We really work we analyze the actual workflow used by the asset owner and the ISPs by going on the ground, witness what they do, and work with them to see how this could be optimized with the use of a digital tool. So this is how we get to the actual status of the solution. And this is what we want to keep doing, of course, in the future for all our digital solutions.
One question I had was in relation to how you take some of the data forward. You showed how the data can be approved and sent to the asset owner. Are there ways that the digital data can be shared, for example, to the asset owner's plant management databases, or used made available for statistical analysis for integrity management?
In fact, today the status is the information is sent back to the IDMS, which is the data software used by the asset owners. Now,
okay,
from there, what can be done with this information? I mean, I can almost say that everything is possible, but today we haven't defined any extra steps yet, but we're working on that. As an example, adding deficiency models to speed up the analysis of all those multiple reports. These are things that we have in mind for version 2.0.
Excellent. Yeah, no, it was very good to see it linked through all to the plant isometrics and the way the approval process, people could add comments and things like that to it. Any more questions for Andres at this time?
Hey, Andre, this is Mark Lozef.
Hello, Mark.
Hey, good to see you again.
Good to see you.
Yeah, it's a big progress with the development of the software. In your future plans for the advanced instruments, do you plan to have automated data analysis incorporated in the process?
As you notice, when I talk about the Olympus Cloud, there is a marketplace where we can have applications, and the version 3.0 has all the required features to host third-party applications. So this we can think. I cannot tell you for granted, but we can think of adding some advanced analysis software to run the analysis of unscanned data, as an example, available for the customers. So we can think of something like that. So I cannot tell you more now because all this is kind of part of work that we are doing and maybe not publicly released. But this is everything is there to make it happen. So stay tuned. You'll know more.
Okay, next year, next 2 years.
Hopefully, quicker than that.
Okay, thank you.
Perfect.
Thank you.
Any more questions for Andres before we move on to the next talk? Great. Well, thank you again, Andre. A very impressive set of cloud solutions there, going all the way through the value chain for people using NDE. So thank you for your talk. I'll now stop the recording.